Namaste everyone, I am Dr. Amit here. Welcome back to my YouTube channel at the rate Dr. Amit Official, making all the medical subjects simple and high for you. If you haven't subscribed yet, go ahead and hit that subscribe button and stay updated with all our exam focused content. So in our last video, we discussed about gluconeogenesis. In today's video, we are moving ahead in our biochemistry series to very important concept on HMP Shunt, hexose monophosphate pathway, or we also called it as pentose phosphate pathway. So this is a very high topic for your US7 Step 1, postgraduate entrance exam and MBBS professional exam. And I will make it simple, clear and easy to remember. So stay focused and stay tuned. So let's start our to a topic HMP Shunt. So let's start our to a topic pentose phosphate pathway, hexose monophosphate pathway. Okay. So first we'll talk the basic concepts of HMP Shunt. Then we'll look on this diagram. Okay, in this on this pathway. So while talking about HMP Shunt or hexose monophosphate pathway, so it is defined as it is an alternative pathway. Okay, it's not a main pathway, it's an alternative pathway of glucose metabolism. It is also about the glucose metabolism. Okay, so that produces NADPS. Remember this NADPS. Okay, and ribose 5-phosphate. So the main output from the HMP Shunt is NADPS and ribose 5-phosphate. Okay, now why this HMP Shunt is important? This is very important. Okay, it doesn't produce ATP, still it is important. Okay, because in most of the pathway in biochemistry, we always try to know how much ATP is getting produced, because ATP is being used in different metabolism of our body. But in this pathway we don't get ATP, still it is very important. Why? Because it produces NADPH and ribose 5-phosphate. Okay, now we'll try to learn what's the function of this NADPH and ribose 5-phosphate. So while talking about the function of NADPH, okay, so this NADPH protect RBC from oxidative damage, the first, okay, importance. Then it is also used for fatty acid synthesis. Then it is used in cholesterol synthesis, and it is also used in respiratory burst. Okay, now while talking about the importance of ribose 5-phosphate, so ribose 5-phosphate is very important for synthesis of DNA and RNA. Okay, that's why even this pathway doesn't produce ATP, still it is why this is important, we know now. Okay, now where does this occur? Where does this HMP pathway occur? So it mainly occur in lactating mammary gland. Okay, then liver, then adrenal cortex. We all know we have adrenal gland. Okay, so in the adrenal gland we have adrenal medulla and cortex. So in adrenal cortex, always remember this line, cortex. Okay, so it's a site for fatty acid synthesis and steroid synthesis. Okay, then in RBC, okay, RBC don't have mitochondria, so that's why the RBC is totally depend upon this HMP pathway for its protection. Okay, now this HMP Shunt have two distinctive pathway. Okay, one is oxidative and one is non-oxidative. Okay, and this now we'll talk this oxidative oxidative pathway is irreversible and non-oxidative pathway is reversible. Okay, and this both occur in the cytoplasm. Okay, so now we'll discuss about the pathway. Okay, now while talking about the pathway of HMP Shunt, okay, so one is oxidative and one is non-oxidative. Okay, so the oxidative pathway is irreversible and non-oxidative pathway is reversible. Okay, so look over here. Okay, so we have glucose 6-phosphate. Okay, so this glucose 6-phosphate is getting converted to 6-phosphogluconate. Okay, and while converting glucose 6-phosphate to 6-phosphogluconate, we are using the enzyme. You always you have listened most of the time in your lectures in the classroom also, G6PD. This is glucose 6-phosphate dehydrogenase. Okay, and this is a rate limiting step of this cycle. Okay, or we can also say that this enzyme is used in the rate limiting step. Okay, now this, and while getting converted from glucose 6-phosphate to 6-phosphoglucane, we are getting NADPH. Okay, and now we know what's the importance of NADPH. Okay, now this 6-phosphogluconate is getting converted to ribulose 5-phosphate. Okay, not ribose, ribulose 5-phosphate. Okay, and over here we are also getting NADPH as a byproduct. Okay, now so this is the oxidative and this is irreversible. Now this ribulose 5-phosphate is getting converted to ribose 5-phosphate, okay? And this ribose 5-phosphate we use to produce help with nucleotide synthesis, DNA and RNA, okay? And over here the enzyme being used is phosphopentose isomerase, okay? So we are the main thing we are getting over here is ribose 5-phosphate and NADPS. This is important, okay? Because this helps in nucleotide synthesis, and this helps in helps to protect RBC, okay? Now this ribose 5-phosphate also can get converted to fructose 6-phosphate, that fructose 1,6,5-phosphate, DHAP and glycerol DI. So this step is not so important, but just remember that this rate limiting step, okay? This rate limiting step and this ribose 5-phosphate, okay? Now I'll focus on one more thing, that cancer cells are, we know the cancer cells are rapidly dividing and it's constantly making DNA. So the cancer cells, so then that's why the cancer cells need a lot of ribose 5-phosphate, this, okay? Because the cancer cells constantly want to make DNA, and for DNA synthesis they want ribose 5-phosphate, okay? So that's why cancer cell depend upon HMP shunt for ribose 5-phosphate, okay? So in cancer cells this HMP shunt occurs more often, okay? So this is all about the cycle, okay? So just remember that there are two phases, one is oxidative, one is non-oxidative. This is irreversible, this is reversible, and you start with glucose 6-phosphate, and it can also form fructose 6-phosphate directly, or it can go on this way, okay, in this way. And over here the enzyme being used is glucose 6-phosphate dehydrogenase, that is G6PD, okay? So this is all about HMP shunt, okay? So I hope I cover all the important aspects from the HMP shunt. So if you like this video, please share with your fellow medicals and with your friends in your medical college, and please subscribe to my YouTube channel at Dr. Amit Official, and we'll meet in the next video with one more important topic on the biochemistry series. Thank you for watching. Thank you.